This is question number 7. We're told a project is modelled by the activity network shown in figure 5. The activities are represented by the arcs. The number in brackets on each arc gives the time in days to complete the activity. Each activity requires one worker. The project is to be completed in the shortest possible time. In part A for 4 marks, we're told to complete diagram 1 in the answer book to show the early event times and late event times. So let's go ahead and do that. And here now is the template we're given. So the top box is the early event time, the bottom box is the late event time. The first thing I'm going to do is carry out a forward pass. So we're going to consider the early event time for each of these blank events. When we do the early event time, it must be the highest possible number. This is essentially saying what is the earliest possible time we can start any activity that branches off from that event. Looking ahead at this, we've got 1, 2, 3, 4, 5 dummies. We're going to have to be incredibly careful here. So let's first start now with this one here. We can see that activity A takes 5 days. That is the only activity feeding into this event. So we could put now as an early event time, we could have now 5. That means all other activities starting from this event cannot start until at least 5 days have passed. Okay, let's go ahead now and look at this one just here. What we've got then is C. C takes 7. And we can see from here that nothing else feeds in. So I can put now the early event time is 7. So we can start thinking about other activities at the earliest now after 7 days. If we look now, moving on, we're going to look at this one just here. We need the completion now of E and the completion of D. If I want to do D, it's 5 days plus 9 days, which is 14. If I want E, we've got 7 and 8, that's 15. We need to take the highest value as we can't start any of the other activities until E has finished, and that will not finish till at least 15 days. So we've gone ahead and done 3 of these so far. The next one that I'm interested in is this one just here. We can't yet do this one, we need to do this one as this event is feeding into this one right here. So let's look here. I can see now that I've got I, that would take 11 days. I've got 15 here. No other activities feed into this event. So it's going to be 15 plus 11. The earliest I can get to this event just here is 26 days. Let's now consider this event. We've got a dummy. A dummy has 0 weight. So it's 26 plus 0. 15 plus 12, which is 27, so automatically that's higher, or 18 and 9, again 27. So the earliest we can leave this event is 27 days. Let's now consider this one right here. We've got N, which is 36 if we add it to a 27, and we've got M, which would be 34 if we added it now to I. So on this one, we need to take the higher value. We can't consider starting any of the other activities until both M and N are finished. So I can see now that S needs M and N to be finished, as does R. So we can't start this until at least 36 days. So that is my forward pass carried out. What we're going to do now is consider the back pass, and we need to find the late event times. We need to be incredibly careful with all of these dummies and make sure we're finding now the lowest value. So how can I get back to this event? Well, I can go up R, and I'm thinking 53 minus 10 is 43. If I consider coming down to S and then with the dummy of 0, I can simply write that this is going to be 42. On now the back pass, we want the lowest number possible. This tells me that I can delay my project up to 42 days in time before it's going to knock any of the others out of sync. So I can be here ready to start R with 42 days past. I can be ready now at here to start S after 42 days have passed, and it will still be completed within the critical time. And that's what the late event time is. It is the absolute latest we can start the activities that branch out of this event. Okay, we need to now be incredibly careful here. This is the next one that I'm dealing with. So I can come down this way, and if I think about this one now, that's 42 minus 9. 42 minus 9 is 33, but I can come up this way right here, and that is going to give me 31. Now if we look at this one, I want to get back here. The only two routes I can go is up the dummy, 31, 0, so that would be 31, or I can go up M, that will give me 34, 31 it is. Right, let's go ahead and look at this one. We need to be very careful. We can come in via the dummy, we can come in via J, or we can come in via I. That would give me 20, this would give me 19, this would give me 18. I choose the lowest weight. So just think to yourself, how many different ways can I get back to this event? And the answer is now we can come with I, we can come with J, or we can do the dummy. Okay, now we need to be very, very careful on the next one. The next one that I'm going to consider now is going to be this one just here. So we're going to look at this one just here. Now just think about this here. We can get now to this one from either the dummy at 7, which would give me 7. We could get to it from G, or we could get to it from H. If I went with dummy, it'd be 7. If I went G, it'd be 13. If I went H, it would be 9. We take 7. Okay, if I now look at this one, I've got 9. We're coming into this one. 9 from 18, which would be 9. Or the dummy, so that is going to be 7. So lots to consider on that one, and that is quite a toughie. So all we're doing now is looking at the late event time on a back pass, the early event time on a forward pass, and that should now be sufficient for the 4 marks on offer. In part B, we need to calculate the total float for activity M. We must make the numbers we use in our calculations clear. The question carries 2 marks. In general, we can say that the float, and I'll write it just here, the float is going to be the late event time minus the activity time minus the early event time. So all I'm going to do now for M is just go ahead and consider that. So M is just here. So it's 42 minus 8 minus 26. So we can say for M, so this is M, we're going to have 42 minus 8 minus 26, and that's going to be 42 minus 34, 8 days. This tells me I can kick my heels for 8 days before I start M, and it won't now knock the project time off the critical time of 53 days. So I've done that part's done as well. Okay, part C. For each of the situations below, explain the effect that the delay would have on the project completion date. So 2 marks in total. 1, a 2-day delay on the early start of activity P, and 2, a 2-day delay on the early start of activity Q. So if we look at P, P is non-critical, which means we have a float. So if we look now at the float of P, and we're not expected to necessarily work this out, the float is going to be 42 minus 11 minus 27. So that's going to be 38. So the float is 4 days. So 2 days will not, change the critical time, will not influence the critical time. So 2 days will not influence critical time. It's not a critical event, and it has a float of 4 days. So 2 days is not going to do anything. If we now look, so 2 days, and let's just check I've done that, that's perfectly fine. So that's P. So we've done that 42 minus 11 minus 27. Okay, a 2-day delay on the early start of activity Q. So let's go ahead and find activity Q. Now activity Q is a critical activity. That's a critical event. That's a critical event, and the difference between them is the activity time. So whatever delay I put on a critical activity will have a knock-on of the same amount on the project time. So we can say that it would be a 2-day increase to the critical time of the project. So 2 days increase critical time of the project, therefore we would go out to 55 days. Therefore 55 days. Critical activities cannot be delayed. Whatever they're delayed by is going to be the amount that you're going to have to add to the critical time of the project. So 2-day increase on the critical time of the project if we delay Q. If we look here, S, if we delayed S by 3 days, we'd go out to 56 days. And again, you can look and see which are the critical activities. Now, while we're here, we can see that these are critical events, these two, but H is not a critical activity because the difference between them is not the same. H still has a float on here of 2 days. 28 minus 19 minus 7 is 2. Don't get caught up thinking that that is a critical activity because these are the same. This is the critical activity here because the difference is 10. Critical events, critical activity. They have a float of 0. We cannot delay them. Okay, now we need to calculate a lower bound for the number of workers needed to complete the project in the shortest possible time. So this is part D. All we do here, and they've been kind enough to work this out for us, we take now the total number of days, which is going to be 172, and divide it by the critical time. Now we've just got the critical time down here as 53. So all I'm going to do is do that. It's essentially the lower bound. Now this is the mathematical lower bound. It's mathematical, it's in theory. It's not always going to be the case. So let's go ahead and get a calculator and work that out. Right, where are we? Here we go. 172 divided by 53, and then we round up to the next integer. So we can say that that's going to be 3.245, which therefore is going to be now a lower bound of 4. We cannot complete this on time with any less than 4 workers mathematically. Now, it might be the case that we need a lot more, but it's just simply saying that even if we allocated this to 3 workers, they simply will not have the man hours or woman hours to get this done in the time. So lower bound is simply now the total activity time divided by the critical time, and then you round up to the nearest integer. Okay, diagram 2 in the answer book shows partly completed Cascade chart for the project. In part E for 4 marks, we need to complete the Cascade chart. Okay, let's go ahead and do that. So we're being offered 4 marks for this. So let's go down, let's go down. So we need to complete this. Now, we've already got the critical path on here. We've already got A and B. And we're told that the dot represents the float of each activity. Now, this is 4 marks. If you're struggling in an exam with your timing, I would suggest coming back to doing this purely based on the fact that it is quite laborious. Now it's going to become even more laborious by the fact that I'm using the computer because it's going to take ages. So if you just want to sort of skip on, you're more than welcome to do so. What I'm going to do is just consider the ones that they've already done such that I'm not missing any out. I'm going to do them alphabetically. So we've got A, B and C. Okay, so A, B and C are done. We don't need to do those. F, L, Q and S are the critical path. F, L, Q and S. So where's F? F is done, we've done L, we've done now Q, and we've done, where's S, just here. So we've got all of the others to add to a Cascade or Gantt chart. So you can see it's quite a lot of work. Okay, so let's go ahead and start that. So I'm going to start with D. Now I like to think of 3 different times. 5, then I'm going to add the 9, which will give me 14, and then 18. I say to myself 5, 14, 18. 5 is the earliest we can start, 14 is the earliest we can finish, 18 is the latest we can finish, and I'll do that. So in my head I'm saying D, 5, 14, 18. So what I'm going to do is put this on. Let's go ahead and do that. We'll put this just here. So let's find 5, there's 5, and we need 5, 14 and 18. So I'm going to put it just here. Now with mine, it might not be bang on accurate, purely based on the fact that I'm dealing with, well, as you can see, it might, and apologies if it's not bang on. I'm going to try and make it as good as I can do. but we'll give it a go. So what I'm going to do, I'm going to put D there. So D, that's done, and then this is the float. So we can see now that we got a float of 4 days on this one. And again, you might want to fill that out and make it look a little neater. So that's D sorted. D, I'm just going to circle. Let's do E. 7, 15, 18. So 7, 15, and 18, and we'll do that. So let's locate 7. 7 is going to be just there. So 7, 15, and 18, and I'm going to plonk that just there, and there's 15. So do be very accurate, because if we come to use this later on, we might need to be very accurate. So that now is going to be done. We've just got to put that on. That's the float. We can say that this is going to be E. So let's go ahead and put E on, and then I'll just circle it. F is in the critical path. They've already done that. G, 7, 12, 18. So let's do G, 7, 12, and 18. So again, we're halfway between. I'm not really favouring these purely based 7, 12, 18. Right, let's put that just there. Purely based on the level of accuracy that I can get on here. So let's put 12 there, and that's going to be G. So let's just do something like that. I'm more concerned about the vertical lines straying over. So let's go ahead and do that. So let's do G, 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 G. So G goes out. We've done G. That's fine. We've got G done. H we need to do. Just be careful. I've not really made that massively clear. So 7, 26, 28. So let's do that. 7, 26, 28. So starting again on 7, as accurate as I can be, going out to 28 days. And then we'll put 26 on. So 26 is the earliest I can finish at. 28 is the latest I can finish without knocking off now the critical time. So that is H, and I need to circle that. That nearly hid from me. Now we're going to look at I. We got 15, 26, 31. So 15, 26, 31. So where's 15? 15 is going to be there. And we'll try and make that accurate. 26, and this goes out to 31. So if I just do that, that's about as good as it's going to get. And then what did we have? 15, 26. So let's put 26 just there. There we go. And it'll look something like so. So all I'm doing is just putting this on. It's not perfect, but hopefully you're getting enough of an idea of what needs to be done to do that. So this one I can label up I, and then I can put a little circle on that just to tell me I've done it. What I don't want to do is come back and realise that I've missed one. J, 15, 27, 31. So 15, 27 and 31, let's do that. So here's 15, we were there before. 27 and 31, so let's put 31, which is going to be just there. And then we got 27. 27 looks to be about there. Okay, so that's as good as it's going to look on the screen. Let's just do that. And so that one now is going to be J. J is clearly not part of the critical path, as it's got a float. Critical activities, as we know, have a float of 0. They cannot be delayed, or they'll have a knock-on effect to that time. K, we've got 18, 27 and 31. 18, 27 and 31. So 18, 27 and 31. So that looks pretty good. So there's, what's that, 31, 18, and we need 27, which is going to be just there, and 31. So that's that part done, 18, 27, 31, and this now is going to be K, so let's put a circle around K, and we've got that. Okay, so K is just here, and then we can put the float on that part right there. Okay, let's now go ahead. So that's K. L is part of critical path. So we need M. We've got M, and that's going to be 26, 34, 42. 26, 34, 42. So 26, let's find 26. There's 26, 34, and 42. So there's 42. And let's try and get that. Okay, that's as good as it looks it's going to go. 34, 20, 26, 34, 42. So let's locate 36, which will be just there. And then it'll look something like that. Okay, so let's shade that in. And that one is going to be M. So L is in critical path, and that is going to be M. Okay, so that's M done. Let's go back. As you can see, this is just a lot of work. 27, 36, 42. 27, 36, 42. So let's do that one. 27, which is going to be just there. 36 and 42. So 42 we know is just there. And 27, 36, 42. And it'll look something like that. So let's do that one. And that is N. So N, clearly not part of critical path. Got a big old float on that one. So that is N. 27, let's just go ahead and check. 27, 36, 42, that's done. So N is done. We are left with P and R. So we've got now 27, 38, 42. 27, 38, 42. So 27, just there, that's where we were before. 38, 42, there's my 42. And 38 is just there. 27, 38, 42. And we'll just drop that like so. Okay, and then just doing this. So as you can see, we've been going 21 minutes, and we're not massively near the end of the question. So that's going to be P, isn't it? So let's just put that on. P. So let's do P, and then finally, what have we got left? R. Is it R? Yeah, 36, 46, 53. So 36, 46, 53. So let's put that one there. 36. So 36, where's 36? 36, 46, 53. Let's just change that. 36, 46, 53. 36. And again, it will be a lot easier when you have the paper in front of you rather than having to scroll backwards and forwards. And that takes us out now. Let's put 46 on there. That takes us out to the critical time. Okay, so that now is R, so let's put R on here. So R is there, and that is done. So what does a Cascade or Gantt chart show us? It tells us which of the activities must or might be happening at certain times. So if we look at this now, we can see, D must be happening at this period right here because we can't move it anywhere. We can see at this time period right now, H must be happening. We could see at this time period, M might be happening, but not necessarily. And you might be asked questions like that. Which events must be happening at this time? Which events might be happening? Right, okay, so we've done that. So there you can see 4 marks can take a lot of time. In part F, for 2 marks, use your Cascade chart to determine a second lower bound of the number of workers needed to complete the project in the shortest possible time. You must make specific reference to times and activities. Okay, so we are being asked a question like that. What I'm going to do is take my ruler and now read from left to right. I'll just change the colour of that so you can see this slightly easier. Let's go ahead and do that. Let's change that. We'll change this to, let's have a go with that one. That should hopefully work. Right. Now, if I go across here, I can see at this point in time, C definitely has to be happening. A has to definitely be happening. Now here, I'm going to start moving things across. I think there comes a certain point in this period here where we need 5 workers. So if I put the line here, what we can do is, look, I can't now have this one not happening. H must be happening, I must be happening, J must be happening, and K must be happening. See, if I move this just here, if we look now at the float here, we've got 3 either side, and we've got 1, 2, 3.5. So if I can make some reference to this point right now, requiring now, and I'm going to put now between 24 and 26, and we could do this. We could say now, let's say at the start, so at the start, so let's find a point. And again, the accuracy of this might let you down. At the start of the 26th day, at start of day 26, remember 26 days have been completed here. This line in the middle, let's just put that there. And there are other options for you. This is just one of them. We can see now that the activity, so let's just write this down. At the start of day 26, okay, which is 25 on here. At the start of day 26, activities, so activities, we've got L, H, I, J and K must be happening. They must be happening. This now gives us a new lower bound. Therefore, lower bound is going to be equal to 5. So all I've done is picked a point right here. You could look to pick other points. The more accurate your Cascade or Gantt chart is, the easier this is. So at the start of day 26, we need all of these activities to be going. Therefore, now we need 5 workers. Mathematically, our lower bound, if we go back earlier, said that we needed mathematically at least. That doesn't say that we're going to do it in 4, but mathematically, if we divided all of the activities up by the critical time, we'd need 4. So that's done. So we're going to state that. So in part G for 2 marks, state which of the 2 lower bounds found in D and F is better. Give a reason for your answer. Well, it's going to be the Cascade chart because the lower bound is higher. So we'll write now the Cascade or Gantt chart. So Cascade chart as LB is higher. Now, the advantage of the Cascade or Gantt chart in terms of the scheduling issues is that we can actually see which activities must happen at certain times. So we've now completed the question, Cascade because the lower bound is higher, and I would actually potentially state we can see which activities must be happening, and this is a realistic lower bound, whereas the other lower bound we worked out was purely mathematical and didn't take into consideration precedence or when activities must be happening. So for example, now if I had activity P and we were somewhere over here, whilst it would still have a lower bound of 4, mathematically it would have to be 6 because there might come a time when you can't move these out of the way such that you only have 4 workers working. And that's his point right here. We can't shift these out of the way such that we have now, because I can see I've got 3 days this side and 3.5 days here, and all of the others are quite clearly not going to be able to move. So something along those lines, the Gantt chart just gives us an idea of what's going on rather than purely a mathematical lower bound. So let's just check we've done everything. That looks pretty good. So 17 marks. 17 marks is a fair old chunk for one particular question. This is quite tough in terms of your dummies, but hopefully the video has been useful in terms of both answering the question and then looking at some of the other issues beyond the scope of the question and more to do with the topic.